Hey, welcome back. Mr. Smith here. In today's video, we're going to take a look at the metric system and do a quick review of some graphing calculator skills, as well as some stuff on what they call the factor label method of conversions. All in all, these are skills that are really important to be confident at if you're going to have a successful year in physics, because they're part of your everyday routine of working with numbers. So to begin with, in physics, we have some units that are called standard units. That means that these are the ones you want to have written down, and these are the ones you want to have on your numbers before you grab the calculator to plug into them. So if I ever have centimeters, for example, then let's go grab a pencil here. If I ever have centimeters, then what that means is I'm going to want to do a conversion and convert that thing into meters. Okay, so we'll show you a couple of examples, but before we do that, I want to introduce this table of metric prefixes. The table you're looking at right now is going to be something that you're given on every quiz or test, so you don't have to memorize it. But these are the 6 most common prefixes and the ones that we use a lot in doing our science. So the thing I want you to notice is just that every symbol is connected to a word, and it's also connected to a number value. So centi is represented by letter C. It means 10 to the minus 2. So I'll show you in practical real life examples how this works. What we're going to do most of the time are problems that are just this simple. We'll be given something like 120 millimeters, and I'll recognize, hey, that's 2 letters written side by side, and I'm going to want to get rid of the first one to turn this guy into a standard label. So I'll go ahead and type, or write rather, 120, and instead of writing the first M, that's a metric prefix, what I'm going to do is go to my chart and just look up that milli means times 10 to the minus 3. So I'll write 120 times 10 to the negative 3. And I didn't change the meters part of that. That's still lying around. And there we go. And what I'm going to do is then reach for my graphing calculator, and I'll just go over and enter it over here. So I'll type 120. I'll hit the EXP button on the bottom of the calculator. And you remember that there's 2 minus signs. I want the lower one when I'm using the exponent, negative 3, and I'll hit EXE, and bang, there you go. I end up with just 0.12 meters. Okay, example number 1. Most of what we do this year is exactly that simple. You don't need a factor label, you don't need anything fancy, you just do it just like that. So next example, we'll have something like convert 24.5 centimeters to meters. Again, I'll recognize 2 letters means I have a compound unit. There's a little metric prefix going on. We'll erase or not write the centi part of it. Instead, we're going to write the number part of it. And again, meters is still lying around. We'll reach for our trusty graphing calculator, and we'll enter the 24.5 EXP negative 2 this time, and we'll figure out that that is equal to 0.245 of those meters. Okay, one more that looks a little more complicated, but really isn't, is this, where you have compound units in a fraction. It's really just 2 problems that are exactly the same as what you've been doing. Again, these letters mean numbers, so just go with it. So we have 36. Instead of milli, we'll write times 10 to the minus 3 meters, divided by 12. Now it's a micro symbol, so instead of micro, we're going to write times 10 to the negative 6 seconds. And we'll go ahead and grab our trusty graphing calculator, and we'll write 36 EXP negative 3rd, hit the divided by 12 EXP negative 6, and crank that out, and we end up with 3,000. Big thing I want you to keep in mind is that these units don't go away, they stay. And I'm going to write that like it's a fraction, 3,000 meters per second. Okay. The most common thing you do, that's it. Just grab the metric prefix, pop in the number part of it, and you're good to go. What we're going to show you right now is the more complicated things that you can do with metric prefixes. So our simple conversions, you'll remember, are the ones where we had a kilometer and we had to take that and convert it down to the middle, or a centimeter and we had to convert it into the zone in the middle. There are more complicated kinds of metric conversions than that, though. You might have to jump from something like a gram into a kilogram. That's pretty common in physics. That turns out to be a little bit more work. Also, you might want to jump across this table from something like megameters down to, I don't know, millimeters or something like that. Those where you're jumping across the no man's land involve some factor label conversions. And what I wanted to do was to show you how this table has some buried information in it that will really help you get these quickly and correctly every time. First things first, did you notice that the big numbers on the table, the big powers of 10, are at the top? So there's a hierarchy here. The big numbers are here, the little numbers are down at the bottom. You're going to file that away and use that, because in doing factor label conversions, the key to getting it right is to realize that one of the big things always equals a lot of the little things. What's an example of that? If you had a dozen, that equals 12. Well, a dozen is the big thing, and it's describing 12 of the little things, like maybe a dozen eggs. A dozen eggs equals 12 eggs, but the word dozen is bigger than a single egg. If you had kilometers, a kilometer is bigger than a meter. So we're going to use that idea in just a second. There's also some math that's buried in this that's really important and can help you save time and iron out a big problem. If you look at mega and you focus on the exponent of it, the 10 to the 6 part, and you look at kilo and you focus on the exponent part, the 3, then that means there's a gap, a difference between the 6 and the 3 of 10 to the 3, or 1,000. That's a 1 with 3 zeros after it. That idea that you can look at the exponents and get a gap between them is really, really a powerful idea. So if I were to look across, let's say two that are pretty far apart, we'll take kilo and milli. So kilo is 10 to the positive 3, milli is 10 to the minus 3. There's a gap of 6 between 3 and minus 3. So I'm going to file that piece of information away and use it when I get to the harder metric conversions. But first, we're going to take a quick refresher break and look at how to do the factor label problems. So you used to know how to do ones like this, and you've done them before. If I had 50 feet and I had to convert it to inches and I had to show all my work, then I'd write down 50 feet. And then I want to put into practice that idea that I talked about, where you use the idea of a lot and a few. So feet is a thing we're going to have to put here. Why? We have to, because we need to cancel it. Inches I put here. Why? Because it's what I want to end up with. So the very first thing that I do is I focus on the labels, not the numbers. Focus on the labels. Get those right, and the numbers will take care of themselves. Second part is simple. Which one is bigger, a foot or an inch? A foot's bigger. So what I do with my logic is say one of the bigs equals a lot of the littles. One of the big ones is the foot, equals a lot of the littles, and I know that 12 is the conversion factor between those two. So I just go ahead and multiply those things, and I'll end up with 600 inches in 50 feet. Okay, I think that's right. Did I multiply that correctly? Yeah, that's right. Okay. In the next example, what I'm going to do is convert from days into seconds, and the way I'm going to do that is by diving right in by writing down the thing that they give us. And we'll follow all the factor label ideas we just talked about. We'll write days here because we have to. We want them to cancel. And what I'm trying to think of is a thing that's smaller than a day. So what I come up with is hours. I think that one of the big things equals a lot of the little things. And that word a lot is flexible. It's the number that connects these two things and makes them true. So here we are sitting in hours. And I write hours now down at the bottom. I'm trying to think of something smaller than hours. So I'm going to go with minutes because I know the connection. Which of these is bigger, an hour or a minute? An hour is bigger, so it gets the 1. What does the word a lot mean in this relationship? The word a lot means 60 in this relationship. And finally, we're sitting here at minutes, having canceled out the hours, and we'll put minutes down at the bottom of the fraction, again, to cancel them out and end up with seconds. And which one's bigger, a minute or a second? A minute's bigger, so it gets the 1. What's the number that makes this relationship true? It's 60. So I grab those numbers at 1 times 24 times 60 times 60 on my calculator, and I get 86,400 seconds for the answer that I was looking for. Okay, so let's apply what we just reviewed to the metric conversions that we're going to actually do in class. So in this one, what we're going to do is convert 37.5 grams, and we need to convert it to kilograms. Well, you should recognize I need to show some factor label for that. Why? Because it's not one of the super simple ones where I'm landing in the middle. It's one of the ones where I'm coming out of the middle and landing on something else. That said, this is still really common. You do this a lot in physics. So I'll put grams here to get rid of it. I'll put kgs up here because it's what I want to land on. That was all pretty automatic. Now the thinking part. Which one's bigger? A kilo or a gram? A kilo anything is bigger than a regular thing because it's higher on the table. So that's the number that gets the number 1. 1 kilogram equals a lot of the little ones. So what does the word a lot mean? It's what we talked about before. So what's the difference between 10 to the 3 and 10 to the 0? It's 10 to the 3. So I'm going to put in 1 times 10 to the 3, or 1,000, down in my denominator. And when I go and push that into my calculator, I'll get 0.0375 for the number kilograms. Okay. One more that's a little bit more complicated than that would be where I have to convert from milligrams to kilograms. So I'm leaping across the no man's land in the center. And I'll show you that by factor label method as well. 250, let's try, milligrams. And we'll do the same rule. We'll put milligrams down at the bottom, so we cancel that label. We'll put kilograms in the top because it's what I want. And I stop and think. Kilograms in this relationship is the big thing, so it's automatically going to get a 1. And now, because of what we just looked at, the difference between 10 to the 3 and 10 to the minus 3 is a million, or 10 to the 6. So I write 1 times 10 to the 6 in the bottom of my fraction. I go to my calculator and I push those numbers in, and what it's going to tell me is I get 2.5. The calculator is actually going to tell me e to the minus 4. Well, we don't write that because we're not calculators, we're actually humans. We write 2.5 times 10 to the minus 4 kilograms, and that's also the same thing as 0.00025 kilograms. Okay? Anyway, that's how you do it. Bring your questions to class. Take care and see you soon.